The steps that we decided to take for our process include 1, roll stock, 2, punch the holes and slots, and then 3, draw the material, 4, shear, and then bend the edges. For the punched holes, the minimum diameter should be at least 20% greater than the stock thickness, and the hole should be at least 2 times the thickness as well. And the hole's distance from the bend should be 2.5 times the thickness plus the bend radius. I did an example of this. Say our stock thickness is 3/4 of an inch, and we have a bend radius of 1/4 inch. Our hole diameter would then be 0.75 times 120%, which would be 0.9 inches, and then 0.75 times 2 would be 1.5 inches, and that would be the minimum distance from the edges. And then for distance from the bends, we'd have 2.5 times 0.75 plus the bend radius of 1/4 inch. That would be 2.125 inches, and that's the minimum distance from the bends. It'd also be advised that you did the punches in multiple passes with separate patterns to help prevent distortion between the different holes, and just to keep anything from happening. For the drawn sections, we said that this should not be a primary operation before cutting and bending the piece, because that could lead to distortion, and also you might not have enough flow material for the draws. So it should be done before cutting or bending the part, because you don't know how much you'll need. And then for the shear, the slides say that you should keep the clearance for the shear between 2 and 10% of the sheet thickness. From our example before, if we had the thickness at 3/4 of an inch and say a clearance at around 6%, you say 0.75 times 0.06. So then your clearance would only be 0.045 inches, which is pretty small, and because this is negligible, you wouldn't need a shaving operation, just because, there's not enough material to really shave off there, and it really wouldn't affect the part very much, and we'll save money. For the bending operation, because of the shape of this part, it wouldn't really be feasible to do a single bend along the edge, but rather do 2 separate bends. And in this case, you'd have a crack, down the corner, but the part would still remain, it would still retain its strength, and it'd be more cost efficient also. As far as the direction of the bends with respect to the material, if we have the roll direction going this way, the strongest bend will always be perpendicular to the roll direction. Therefore, we said that the 10.8 inch long bend, the shortest bend, should be done perpendicular. Then the longest bend should be done parallel, which would be the weaker bend. We just said this to have the bend strengths to be relatively equivalent, rather than having the short one with the weakest bend and the long one with the strongest. For the annealing process, we said that annealing is between annealing can be done between some of the operations, and will relieve some of the stresses that are built up during the cold working process, and it'll make the part too brittle to work in any of the further operations, and therefore it'd be best to have it undergo this process, which it's heated up to a temperature generally below the metal's austenization temperature, which is between 260 and 760 degrees Celsius, and then held there until their stresses are relieved. They'll be then furnace cooled, and then you can cold work it again. The changes that we made to this part that we felt were necessary would be to change the distance of the holes from each other, as well as have a greater distance from the edge and from the bends. And also, as I said before, the corner, the two side bends should be done separately, rather than a continuous bend. And that's about it. Thank you.